remember to make the notes whenever class is going on. So make a notes. Okay, that's very, very important. Make your own notes. That is very important. Okay. So making your own notes. So therefore, be with notes always. I will share a printed notes in the Google Classroom. But an important point to be noted is, even though I share the soft copy of the notes, it will cover only important points, highlights of the topics whatever I have covered. It will not cover complete detail whatever I speak in the class or discuss in the class. So therefore, it's very important to make your own notes, so that uh, whatever you understood, you can recall later. Okay, that is very, very important. So therefore, make your own notes. Always be with notes. Okay, that's the one thing I wanted to tell. Then, of course, since it is online class, I cannot make it. Generally, I like to have class interactive. I will ask question and again every now and then. But here it may be a bit difficult, but still, let us try to do that. Every now and then I will ask a question. Maybe you can unmute and answer, or you can answer in the chat box. That also fine. Okay. So that is a very important thing. Whenever class should be very interactive. Okay. Let us get into the business. All right. So let us see what exactly the things covered in oscillations and waves. Before going into oscillation, let us see one of the basic points. What exactly oscillatory motion? Oscillatory motion. It's a motion which repeats itself after regular interval of time is called as periodic motion. I'm not talking about oscillatory motion now. I'm talking about periodic motion. What exactly periodic motion? A motion which repeats itself after regular interval of time. For example, a circular motion. Look at that second arm of the clock. It executes circular motion. It repeats at regular interval, that is, at every 60 seconds, it repeats. So it's a circular motion. That's one example for periodic motion. Then what exactly oscillatory motion? A periodic motion which executes to and fro motion about its fixed reference point. It's called as oscillatory motion. So what exactly that? Now from a fixed point, that is simple pendulum, we can take the example of simple pendulum. It oscillates about a fixed point, fixed reference point. It oscillates and it's said to be to and fro. It's a periodic. You can see the motion repeats at a regular interval of time again and again. It's repeats at regular interval of time. That means it is a periodic motion. It's a periodic motion. A periodic motion which is in the form of to and fro. That means what exactly that? To and fro. It tracing same path again to and fro. That is important. Okay. Periodic motion also, it's going in the same path and coming back in the same path. So in the first example, whatever we have seen, periodic motion, I have given intentionally, I have given the circular motion as the example. So there, motion repeats at regular interval, but it is not coming back in the same path. It is not coming back in the same path. So it is going again in the same path again and again, but not coming backward. So in the oscillatory motion, it is tracing backward. That is very important thing. Okay. So, okay. So please remember, all periodic motion need not be oscillatory. All periodic motion need not be oscillatory motion. You can see the simulation. The two motions I have given: periodic motion, one is circular motion. So one is oscillation, that is to and fro oscillation. So second one is oscillatory motion, whereas first one is not a oscillatory motion. That means all periodic motion need not be oscillatory motion, whereas all oscillatory motion will be periodic. All oscillatory motion will be periodic. So therefore, converse is not true. All oscillatory motion will be periodic, but converse is not true. All periodic motion need not be oscillatory motion. So let us get into a step further. So let us see what exactly simple harmonic motion. So we have seen periodic motion, we have seen oscillatory motion. Now let us see what exactly simple harmonic motion. So simple harmonic motion is defined as a motion in which the acceleration of the body is directly proportional to displacement from its fixed point and is always directed towards the fixed point. So that's the definition. Let us try to understand that. So how exactly to try to understand that? So let me go to one simulation. So I'm going to share my entire screen. Can you see my screen? You can reply on chat. So can you see my entire screen? Okay, thank you. All right. So this is what exactly I'll take you into pendulum lab. So here you can see a string attached with a mass. Okay, I'll give a displacement. So is it a periodic motion? Yes, it is a periodic motion. The motion repeats at regular interval of time. So therefore it is a periodic motion. Fine. Is it oscillatory in nature? Yes, of course, it is a oscillatory in nature. There is no doubt. It is oscillatory. It's oscillating between 2 points, to and fro, from a fixed reference point. Whatever dotted line is a fixed reference point, that is its what is that, rest position or mean position. Whatever dotted point is a main position. So therefore oscillation takes place with respect to this main position. So it's a oscillatory motion. Now let us see. So as per definition of simple harmonic motion, what is that definition says? Simple harmonic motion is defined as motion in which acceleration of the body is directly proportional to its displacement from its fixed point and is always directed towards a fixed point. That's what exactly the definition says. Let us see, let us try to understand that. So now I have given a displacement. I'll restart it. So I'll hold here. Okay. And leave. Okay. So it executes oscillation. It executes oscillation. So what it says? Simple harmonic motion in which acceleration is directly proportional to displacement. Just I will tick on acceleration. So maybe it's very fast. I will make it slow so that to understand. So before that, I'll take the velocity that will make you to clear. Okay. So now at the main position, what is the velocity? Velocity, now it's not oscillating, 0. Okay. Now I'll give the displacement. What is the velocity? I have given certain displacement. Velocity is 0. So I'll leave. What you can see is as a pendulum comes down, velocity increases, okay, becomes 0, again increases. When it reaches mean position, you can see the magnitude of the arrow mark is maximum. In other words, velocity is maximum. You can see that. Yes, whenever it passes through the fixed reference point, velocity is maximum. What exactly that? So when it goes to the maximum displacement, velocity becomes 0 at this point. Velocity becomes maximum. Again, velocity decreases. It becomes 0. Okay. Again. Okay. So again, I will show. Okay. All right. So velocity goes to 0. It becomes, as you come down, it becomes maximum at the center. I mean mean position. Again, decreases, becomes 0. So what exactly our definition says? Acceleration of the body is directly proportional. What is acceleration? That is change in velocity with time. Change in velocity with time. Yes. As velocity goes on, decreases. That means velocity is changing with respect to time. That means there is a acceleration. There is a acceleration. Okay. So to understand that, I will give the acceleration arrow. You can see acceleration change the direction. That's very important. Acceleration is opposite to velocity. You can see that. And opposite to displacement. That's what exactly the definition says. Acceleration is always opposite to the displacement. So this is the displacement side. It is opposite now. Okay. And also it is directly proportional to displacement. To understand that, I will take one more pendulum. One more pendulum. So I'll change. Okay. I'll change the length of the pendulum. Okay, same as that of the first pendulum. Okay, so mass also I'll make it same. Okay, both are same. Now I'll give more displacement for the second pendulum and start. Can you see the arrow mark is bigger than the second one, the first one? For the second pendulum, the arrow mark, what is that? Acceleration is more in the case of second pendulum. Do you understand that? So maybe a bit difficult. Okay. So let us do it with the single pendulum. Now I'll give a small oscillation. Okay, I'll give a small oscillation. You can see that slowly it is moving, right? The same pendulum, I'll give higher oscillation. What do you see? It moves faster, right? That means what exactly happens? I have given a more displacement. Velocity is zero at this point. Velocity is zero. As it coming, velocity increases. It is the maximum. That means it has more velocity compared to the first displacement. First displacement. That means if you give more displacement, increase in velocity also more. So that you can understand with the energy graph, but I don't want to get into that. So that's what exactly the definition says. I hope that is clear. If you have any doubt, you can ask me now. Any doubt? Do you have any doubt? If it is clear, I'll go ahead. Okay, there is no doubt as such. Fine. Let us, I think it is clear. Okay, let us move forward. So now, so we have seen oscillatory motion, simple harmonic. Let us see the characteristics of simple harmonic motion. What are the characteristics? First one is, yes, the motion should be periodic. Yes, because simple harmonic motion is an oscillatory motion. The definition itself says it's an oscillatory motion. So therefore, oscillatory motion is a periodic motion. Yes. Second, so when a body is displaced from mean position, a restoring force which is tends to bring it to mean position and direct towards the mean position. In simple, restoring force is opposite to displacement. Restoring force is opposite to displacement. Let us again go back to our pendulum again. Just see that. Uh, so I will give a displacement. So why the now I leave the pendulum, then it goes towards the mean position. Why pendulum is going towards the mean position? Because a force is acting which is pulling pendulum back to mean position. That is nothing but gravitational force. We call it as restoring force. We call it as restoring force. So therefore it comes back to mean position. Comes back to mean position. Since velocity is maximum, it is going the other direction. Velocity decreases, becomes zero, coming back, velocity becomes maximum, again going back. So this is the to and fro motion. So therefore, whatever it says, the second characteristic, the restoring force is opposite to displacement. Yes, which is the direction of displacement. I have given the displacement in this direction. You can see the arrow mark. The restoring force is in the opposite direction. Restoring force is in the opposite direction. The third characteristic, the restoring force is directly proportional to displacement of the body from its mean position. So you can understand this point, restoring force is directly proportional to displacement. If I give more displacement, restoring force will be more. But it's a bit difficult to understand in the case of a simple pendulum. So if you take a mass and spring. So I'll take a weight and add. Okay. Okay. What I will do is, so I'll give a displacement. I will give more displacement. What you can see, it oscillates faster. Or just recall, a spring when you pull small amount, easy to pull. As you pull more and more, What exactly you experience? What exactly you experience? A force which is trying to restore the spring. If you hold a spring in your hand, two hand, and if you pull that, what you experience is spring is trying to pull back your hand. That is nothing but restoration. That is nothing but restoration. A force is acting opposite to your hand displacement, whatever displacement given by your hand. So that is called as restoring force. So if you give more displacement, or if you stretch more, if you stretch the spring more, the force is also more. You can see here, you stretch more and leave, oscillate faster. So if you want to see that, I'll increase the spring constant. Stop it. Okay, I'll give more. You can see quickly it moves. If I give more, yes, it oscillates. So here you can understand that. What is that? So restoring force is directly proportional to displacement of the body from its mean position. So even that is true in the case of simple pendulum also. Okay, so these are the main characteristics of simple harmonic motion. So the first is motion should be periodic. Second one is restoring force is opposite to displacement, or restoring force is directly proportional to displacement of the body from its mean position. Okay. Next, let us see some of the concept you have already learned and forgotten. Okay. First one is displacement. These are the important to understand whatever concept coming next. So therefore, we have to discuss about this. First one is displacement. What is displacement? Displacement is the distance of the particle measured along the path of motion from its mean position at an instant is called as displacement. What is that? Again, let us go back to, okay, here you will understand. I'll remove, okay. So you can see light blue dotted line, that is a mean position. I'll put a spring, uh, wait, and pull the spring. Whatever arrow mark, that is a displacement. That is a displacement. What exactly that? So that is nothing but, so how it is defined? The distance of the particle. So we use word particle. We use word particle. So it is not called as what is that, spring or pendulum, something like that. Reference point is taken, one of the particle in the pendulum or spring. Okay. So with respect to that, we are talking about the distance of the particle measured along the path of the motion from its mean position at a given instant of time is called as displacement. Okay. Next is amplitude. The maximum displacement of the particle on either side of its mean position is known as amplitude. So this again, if you recall the pendulum, so it's a maximum displacement, that is from the mean position, the point at which the velocity of the particle becomes zero. That is the maximum displacement, that is known as amplitude. It will be there on either side of the main position. That is what exactly called as amplitude. So what is oscillation? Oscillation is the one complete to and fro motion of the particle about its mean position. So simply you can say oscillation is nothing but one complete to and fro motion of the particle. One complete to and fro motion of the particle from its mean position is called as oscillation. These are the things you are knowing, but just recalling, that's all. Next, time period. Okay, time period is taken by the particle for one complete oscillation. It's time taken by the particle uh, to complete one oscillation. Simple. It's time taken by the particle to complete one oscillation. That's called as time period or period. It is represented by T. Okay. Now very important next one. So we are developing one by one, step by step. Okay. Frequency. Frequency is the number of oscillation completed in 1 second. Number of oscillation completed in 1 second. It is represented by, there is a relation between time period and mu. So, your teacher is told frequency is inversely proportional to time period 1 by t. So, can anybody tell me, now there is a time for question, why frequency is inversely proportional to t? Or why frequency is 1 by t? Yes, you can, yes, anybody, you can unmute yourself and answer if you know the answer. Yes, why frequency is 1 by t? Or you can put it in the chat box also. Yes, why frequency is 1 by t? Anybody? This is a problem. So, okay, I will ask one more question. When you have asked last question for your teacher, when you have asked your last question for your teacher, anybody remember? Very difficult, right? Yes, you stopped asking question long back. Maybe in your 5th standard or maybe in 1st standard itself. You stopped asking question. Do you remember when you have asked your last question to your teacher? Anybody? Anybody have asked recently, very recently question to your teacher? No. Okay. Coming back. So, whatever here, 1 by t, whatever you see, that is, there is a significance. If you carefully see here, frequency is equal to 1 by t. You have to see the definition. Frequency is the number of oscillation completed in 1 second. Frequency is the number of oscillation completed in 1 second. What is T? T is the time taken for one oscillation. T is time period is time taken for one oscillation. Time taken for one oscillation may be less than 1 second, more than 1 second. We don't know. We don't know. So, but frequency is the number of oscillation completed in 1 second. So this one, so it looks like mathematically it is inverse of period, inverse of period, reciprocal of the period. But actually, this one is nothing but 1 second. This is the time. One is time. That is 1 second divided by time taken for one oscillation. Time taken for one oscillation. Yes, of course. If you divide time divided by time taken for an oscillation, that will give total number of oscillation per second. Total number of oscillation per second. So that is why it is reciprocal of, it's happened to be. You cannot say it is a reciprocal of time period. It looks like mathematically it happens to be reciprocal. Actually it is time, that is 1 second divided by the number of that is time taken for one oscillation. So I think that is clear. So your teacher used to say that it is a reciprocal, so you also believed. You have to ask the question, and then you will get the answer. Okay, next. Next, a very important thing we are going to see, that is a phase and phase difference. Okay, so what exactly phase and phase difference? So, okay, I'm not going to here. I'll explain using, let us go back to our pendulum lab. Stop. So let us take two pendulum. Yeah, two pendulum are there. Okay. Now you are watching. I'm giving a displacement. First, let us take one pendulum. I'm giving a displacement to this. Okay. It is under oscillation. One oscillation is over, two oscillation is over, three oscillation is over. Okay. So oscillation is continuous. Okay. Now let us say I have not, you are not in the class now, but I have said this for oscillation. It is continuously oscillating. It is continuously oscillating. It's already completed so many oscillations. So how you explain, somebody comes in, or I have to explain you. It has already completed so many oscillation. It has completed 10 oscillation. It has completed 20 oscillation, or it has completed 2 oscillations, something like that. How to explain that? How to explain that? Because for you, it looks like it is just now it started. If you come and see now, yeah, it's just now started. One, two, something like that you believe. But it is not so. It's already started. It's already started. So that is known as a phase of the oscillation. That is defined in terms of either t or angle phi. Time period, t means capital T, that is time period, or in terms of time. What exactly? So phase difference of the particle is phase is expressed in terms of period t, that is time elapsed, or total angle 2 pi. Why it is 2 pi? Because complete oscillation is described in terms of 2 pi. That is the starting point here. It is 0. When it comes over here, it is 90 pi by 2. This is pi 180, and comes back here. It is 32. Here it is 2 pi. That is how it is defined. One complete oscillation defined in terms of 2 pi. Why it is in terms of 2 pi, that I will explain a bit later. So a simple harmonic motion can be expressed as a sine wave. That is, I will show that. Then you will understand that. Okay, for time being, just remember that one complete oscillation is expressed as 2 pi. If it is 2 oscillation, it is 4 pi, 6 oscillation, 6 pi, like that. So what I will do is, you ask how many oscillation is completed, then I will say it's completed, its status is 2 pi, 2 pi. That means you immediately understand it has completed one oscillation. I say 5 pi, 5 pi. That means you understand it completed 2.5 oscillation. It came 2 oscillation, again came over here. After completing 2 oscillation, it came over here. Then I will say 5 pi. If I say 3 pi by 2, that means you will understand it is here. After coming back, it's back on the first oscillation. It's at the mean position. I can define. If it has completed 10 oscillation, I can define in terms of t also. I can say 1t, 2t, 3t, 4t, 10t. Immediately understand, okay, it has already completed 10 oscillation. That is something about phase. Now coming to phase difference. What exactly phase difference? Let's see. What I will do is, okay, whenever first pendulum comes, overlaps, I will leave. Okay. Slight difference because I slight variation is here. Yes, phase difference is there. You can see that the time is not proper. If you do it simultaneously, yes. Yes, there is a difference. Okay, no problem. So now, stop. Okay, I'll give from this side. So now, you can see pendulum is oscillating, but can you see we say which pendulum is set to oscillation first, which pendulum is set to oscillate next? That is what exactly we say phase difference. That is phase difference between two simple harmonic motion. That is simple pendulum, simple harmonic motion. How much two motion are out of step with each other, or how much angle, or how much time one is ahead of the other? What exactly that? Stop. So I'll start this. Okay. When it complete half oscillation, I will leave from here. Okay. Okay, they are crossing. So now there is a phase difference of pi, 180-degree difference, exactly opposite. Okay, 180-degree difference. The second pendulum is ahead of the first pendulum by 180 or half t or pi, like that. Even if it is on the same side, after two oscillation is completed, if you leave the second pendulum with the first pendulum like this, so then also you can define the phase difference. So that is what exactly phase difference and phase and phase difference. Is it okay? All right. So any question at this moment? Yes. Any question? You can unmute and ask.
Sir, could you explain more this the definition of phase? This one, the phase is
Phase.
definition.
Okay,
Yeah,
okay, okay,
yeah.
okay, okay. I'll do that. Okay. Any other question? Any other question? Can you hear me properly? Somebody told sound problem. Can you hear me properly
Yes, sir. Yes, sir.
now?
Yes, sir.
Yes, right?
Yes, sir.
Okay. All right. So let me, okay. Now let me once again go back to screen sharing. I'll take that. Can you see my screen? Yes. Please unmute and answer anybody. Can you see my screen?
Yes, sir.
Okay, thank you.
Yes, sir.
Uh, okay, thank you, thank you. Okay, fine. So again, I'll start with the face. So now I'll reset. Okay, pendulum is set for oscillation. It is continuously oscillating. Now you can count how many oscillations. Now you have seen the pendulum is set for oscillation. At what time I have set it for oscillation, and it is continuously for oscillation. Okay, so you can see that. But if you come late, I have already set it for oscillation. Already it has completed an oscillation. So your friend has seen that. Your friend has to explain, or your friend is coming late and you have to explain to him. How you do that? So 10 oscillation, 10 and a half oscillation is completed, something like that. So to define that, either period t or angle 2 pi is used. Either period t or 2 pi is used. Angle is used. Uh, okay. Phase is nothing but it is explaining state of motion. State of motion. At what stage it is. State of motion of the simple harmonic motion. At what stage? In simple, how many oscillations are completed? That is what exactly explained by the phase. Okay. So if I say 2 pi, if your state of the motion is 2 pi, that means immediately you should understand one oscillation is completed. If I say 5 pi, that means 2.5 oscillation is completed. 2.5 oscillation is completed. If I say 11 pi, 10.5 oscillation is completed. Like that. Okay. So that is, it is explaining state of motion of the pendulum. That is phase. That is phase. Okay. What is phase difference? Phase difference comes into picture whenever there are two harmonic motion. Phase difference will not come into picture when there is only one harmonic motion. When one pendulum is there, there is no question of phase difference. Phase difference. Okay. Phase difference will come into picture only when there is a two simple harmonic motion. That is, I am taking second pendulum. Second pendulum. Okay. So its length is big, no problem. So that also set it for oscillation. It is also in the simple harmonic motion. Now how to explain at what time second pendulum was set for oscillation? Now this is completed on oscillation, 2 oscillation, 3 oscillation, 4 oscillation, 5 oscillation. Okay, with that you have left. So that means now if you look the oscillation, you don't think what is the difference between them. So I have took after 5 oscillation, I have set second pendulum for the oscillation. There is a phase difference of 5t or 10 pi. 10 pi. 10 pi. There is a phase difference. I say there is a phase difference of 10 pi. That means what you have to understand is second pendulum is set for oscillation after first pendulum completed 5 oscillation. Is it making sense? If I say there is a difference of 10 pi, 10 pi, the meaning is first pendulum is completed 5 oscillation when second pendulum is set for oscillation. Just looking at this oscillation, you cannot say that. So already first pendulum was under the oscillation. It has already completed 5 oscillation. If I say there is a phase difference of 11 pi, what you have to understand is first pendulum has completed 5.5 oscillation, then you have set the second pendulum into oscillation. Is it clear? Is it okay? Rahul, is it okay?
Yes, sir. I got it.
Clear?
Yes, sir. Yes, sir.
So one more time, sir.
Huh?
Can you
One
explain
more
that one
time.
more
Okay,
time,
no
sir?
problem.
Yes.
Which one? Phase difference or phase?
Phase difference, sir.
Phase difference. Okay, 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 okay. Well, phase is clear, right? Phase is clear, right? Phase
Yes,
is
sir.
Yes, sir.
explaining about state of motion of the simple harmonic motion. Okay, phase will be there when there is a one pendulum. You should be clear. One pendulum in the sense one harmonic motion. We are talking about phase whenever there is one harmonic motion, simple harmonic motion. Phase difference will come into picture whenever there is two or more oscillation. Especially it's to understand two oscillation is enough. Okay, whenever there is a two oscillation, the phase difference coming to picture. Okay, so again let's say first pendulum is set for oscillation. It completed one oscillation, two oscillation, 2.5 oscillation. I'll leave. Okay, you can see the pendulum is moving exactly in the opposite directions, correct? Okay, they are moving in the opposite direction. All right, but looking at that, you cannot see. Looking at that, you cannot see. So important thing is I'll stop, because if a pendulum length is difference, then the period of oscillation will be different. So it will be a bit confusing. So I'll reduce the length of the second pendulum also. Mass is not a problem. Okay, first pendulum I set it oscillation. Okay, it completed one oscillation. Two and a half. Yes, I'll leave. Okay. Now, if you look at this, what do you think? There is a difference of half oscillation. Looks like that, is it not? When you look at this, just if you come and see this, it looks like they are exactly opposite. There is a difference of half oscillation. But actually, first pendulum has completed 2.5. Correct? Then 2.5 oscillation is completed. You left the second pendulum to oscillate. So to define that. So how many pi? Now you tell me. Answer. What is the phase difference? 2.5 oscillation. What is the phase difference? Rahul or Pawan? Can you answer me? What is the phase difference now? 5 pi. 5 pi. One complete oscillation is 2 pi. Okay, one complete oscillation is 2 pi. Two complete oscillation becomes 4 pi. 2.5. That is 5 pi. 5 pi. There is a phase difference of 5 pi. Is it okay?
Yes, sir.
Clear? Pawan?
Yes, sir.
Is it okay? Okay. So that's what exactly. So I think okay, I'll go back to okay. This is what exactly uh, the top phase and phase difference. Right. Next, we'll see some of the examples for simple harmonic motion. These are all things you know. Just a mass attached to lower end of the spring. Already you have seen. I have taken and pulled the spring, and it is undergoing oscillation, compression, and extension. So that's what exactly. So that's a simple harmonic motion. There is. It should be oscillatory. Is it oscillatory? Yes, it is oscillatory. Whether acceleration is directly proportional to displacement. Yes, it is true. A bob attached a string, that is also true. A stretched wire, you can see in the musical instruments. The wires are fixed, and tension is given. If you pluck, the sound will come. Why sound will come? Because wire is executing simple harmonic motion. Simple harmonic motion. That simple harmonic motion will be transferred to air molecule surrounding to the string, and air molecule also start vibrating in simple harmonic manner. So you will hear the different sounds. Okay, this is okay. Since both are similar, a air molecule executing simple harmonic motion. This is what exactly a speaker, a diaphragm of the speaker executing simple harmonic motion moves simple harmonically. Diaphragm executes simple harmonic motion. So that propagates, that produces sound wave that propagates through the air. Air molecule also executing simple harmonic motion. Carefully see that animation. You understand the molecule is not moving. The just the compression and refraction. Molecule is not moving. Just propagation of the energy. Propagation of the energy. Or air molecule is vibrating to and fro. To and fro. Okay. So I think it is time now. So you have to join next class. So we will stop for today. Any doubt? Any doubt? If you have any doubt, you can ask. Yes. Any doubt? If you have any doubt, you can unmute. Uh, okay. Okay. So important thing is, okay. Important thing is, I think two people have joined and left the meeting. So important thing is, some of the announcement I have to make. One is, in the Google Classroom, you have to join with your USN based email ID. Some of you have joined with your regular ID. And the second thing is, your name should be USN, display name should be USN underscore your name, because why am I insisting, because otherwise later there will be a problem. Because problem is, whenever we download your grade card or other thing, then the things are not displayed properly. If you write display name in this format, the one column USN number will come, the second column name will come, next marks and other thing will come. Similarly, during meeting, why we are insisting USN underscore your name is, in the meeting also attendance is recorded. That recorded attendance of course comes in the form of Excel file. Again, one column will be USN number, another column will be your name, and next column that is attendance. So therefore it's very important, very important. So therefore, those who are not changed your name as display name as USN underscore your name, please change in the Google Classroom. Those who have joined with your regular email ID, you can call me, request me again for the invitation for to your USN based email ID and join with the USN based email ID. That is very, very important, because throughout this semester, this is a online class will be going on. So you have to keep your display name as USN underscore your name. Maybe some of you are active in YouTube, and maybe you have the channel and other thing. Then there will be a problem. Your name will be displayed in the YouTube channel also as USN underscore your name. So your general mail ID you keep it for other purpose. For this purpose, you keep it exclusively this USN based mail ID. Okay. So thank you for joining. Let us see tomorrow. So I'll end the meeting. You can join to next class. Thank you.